With our today's never-ending development of electronic equipment with higher and higher power density, there is much more heat generated in a smaller envelope. This makes it more or less impossible to use the traditional air cooling as a method. By implementing quick connectors in the early stage, you can do sub-assembly testing. And once you come with your sub-assembly to the final assembly, you can easier just connect them and you're up and running much faster. It's a kind of plug-and-play system. This is also important later on out in the field if you need to do an upgrade, you need to do a field repair. So if you are in a very remote location, it's much easier that you just disconnect and connect the new system. There's no need for evacuation and drain of the existing liquid. You just come there and connect and disconnect, which saves a lot of time and money out in the field. Here it's important that you select a good combination of materials. You have to think about the selected fluid together with the components as the cold plate, the tubing, the fittings, the quick connector. You need to make sure that it's a good combination in order to avoid any problems like galvanic corrosion in the long run. Also, you have to think about the application parameters, because every individual application is different. You have to think about things like vibrations. Is there any shock? Is there a large temperature interval in the system? When you come to the actual quick connector, make sure that you select a coupling that is spill-free, because of course you don't need to have a spill when you disconnect near your sensitive equipment. Also, a quick coupling with low air intrusion is good, because trapped air into a liquid cooling lowers the heat transfer effect. But at least you need to think about good and reliable quick connector that's been proven for liquid cooling systems. Because in these systems you disconnect very seldom, and you want to make sure that it shuts off properly when you disconnect. All the pressure drops counts from all the components in the system. You have the pump, you have the tubing system, you have the cold plate, you have fittings, you have quick connectors. All of these pressure drops individual adds up to the system pressure. This system pressure decides the pump size. And if you have a too high system pressure, you have to perhaps upgrade your pump size. This means a higher investment cost for you. Also, if you can select one size smaller quick connector, that will lower your initial cost too. The pump pressure is also, if you can manage to have a lower pump pressure in the system, you also lower the electricity bill for the pump, which is good in the long run, of course.